We all know that extreme weather events like hurricanes and heat waves are getting worse due to climate change.
From scorching heat waves to heavy flooding, extreme weather events have caused widespread upheaval, with thousands of people killed and millions more displaced. Scientists say much of this is what's expected from climate change.
But this is often discussed in vague, imprecise terms. Worse, more extreme, more dangerous.
Scientists predict the changing climate could mean more extreme conditions.
What scientists would really like to know is how much worse, how much more extreme. And if we can calculate that, could we even say that a particular storm wouldn't have killed this many lives or wouldn't have destroyed this number of homes if it hadn't been for the pollution of companies and governments?
That's actually a question I've been trying to get the answer to.
That's Michael Wehner. He's a climate scientist at Lawrence Berkeley National Laboratory, where he uses climate modeling to try and answer these questions.
So these are some of the latest kind of developments in trying to merge the physical science that I do with the social science that some of my colleagues can going from a degree of warming to environmental injustice is what I call end-to-end.
End-to-end attribution would hopefully allow scientists to calculate the exact degree of damages due to climate change from extreme weather events. It's not hard to see how these calculations would be powerful both politically and legally.
This was really, a result of advances in high-performance computing, the fastest computers in the world, of which we're really fortunate at Berkeley Lab to usually have one that, at least when it's new, is in the top 10 fastest computers in the world.
Wehner is a leading expert in climate modeling, and his data has led to some startling revelations about precisely how much worse climate change is making extreme weather events. And his latest discovery made a huge stir.
Over the past few years, we've seen enormous damage from weather events all around the world, and that includes devastating hurricanes. And now some scientists say the scale used to rate those storms isn't high enough.
A recent study published suggests that since hurricanes have been getting stronger, thanks in part to warmer ocean waters linked to climate change, that another category, a Category 6, should be added to the current 5-category Saffir-Simpson scale.
It's terrifying to imagine that climate change is making storms so much worse that we may need a new category of hurricane.
There weren't any before 2013.
It's even more terrifying to learn that these storms are actually already happening, whether we add that category or not. Since 2013, there have been
5, one every other year on average. But we wrote this paper to warn the public about the dangers of climate change. We have more global warming in the pipeline, for certainly the rest of my life. And so we need to be able to understand what those dangers are, how they're going to get worse, and take action to reduce the suffering.
And Wehner hopes that these advanced climate models may be able to help us do just that.
Well, it's often said that knowledge is power. And so the better these models get, the more knowledge we have. And that means we have more information to try to take action. So we have 3 choices. We can mitigate, adapt, or suffer. I'd rather not suffer. I'd rather have us do one of the first 2. If we're not going to mitigate, we have to adapt.
Welcome to Big Brains, where we translate the biggest ideas and complex discoveries into digestible brain food. Big Brains, Little Bites from the University of Chicago Podcast Network. I'm your host, Paul Rand. On today's episode, calculating how climate change is making extreme weather worse. Big Brains is supported by UChicago's online Master of Liberal Arts program, which empowers working professionals to think deeply, communicate clearly, and act purposely to advance their careers. Choose from optional concentrations in ethics and leadership, literary studies, and tech and society. More at mla.uchicago.edu. Ever wonder what it looks like inside some of the world's most advanced laboratories? And how the groundbreaking research is conducted? Check out a new UChicago video and Q&A series called Inside the Lab at news.uchicago.edu/insidethelab. Well, Michael, I wonder if we can just simply get started by having you give a little bit about your background and how you first got interested in studying extreme weather events and climate change.
Well, that's actually an interesting story. I've always said I'd rather be lucky than smart, and this is a clear example of that. I got interested in extreme weather at a conference on statistical climatology back in the late 1990s. At that meeting was mostly statisticians and climate scientists, and they were supposed to be talking to each other, but they were kind of talking at each other. And I heard this talk on extreme value statistics, and I was attracted to this mathematics because it was particularly elegant. And as I started thinking about what this kind of math would be useful for, I realized that it would be good for describing extreme heat waves, particularly, and extreme rainfall. That sort of evolved into hurricanes and tropical cyclones. And I kind of got lucky again on that, in that one of the things that I'm good at is computer modeling. And at that time, I was running some of what was really the state-of-the-art climate models in terms of the highest fidelity, the highest resolution the computers of the day could handle. Up until that point, the book was that climate models didn't simulate hurricanes. And even today, most garden variety climate models that are used for, say, the U.S. National Climate Assessment or the Intergovernmental Panel on Climate Change, in which I've been involved in for some years, are too coarse to resolve these storms. They typically divide up the planet into little boxes of 100 kilometers, it's about 60 miles or so, or maybe 200 kilometers. Tropical cyclones are not a lot bigger than that. And so it just doesn't have the fidelity to simulate these storms. But what we were doing with these high-performance computing was pushing that resolution down to first 50 kilometers and then down to about 25 kilometers. And that's still coarse by hurricane simulation standards, but it is reasonable enough to produce fairly realistic storms. And as I looked at this, I was chasing down a bug, actually. And as I was looking at the data, I realized that this weird thing crossing the Pacific was a hurricane. And I got all excited, called up my boss and said, "You won't believe this, you won't believe this." And it took me a long time to write the first paper because I didn't know anything about hurricanes at the time. And I spent a lot of time trying to educate myself about what it was I was seeing in these computer simulations.
All these computer models led Wehner to make a disturbing realization. The hurricanes we've been seeing in the last few years have been getting exceptionally worse. So much so that they are exceeding what could reasonably be expected from our highest category of storm, Category 5.
And that's what our Category 6 paper is all about. So we have this basic theoretical understanding of what makes a perfect storm. And so we basically presented 3 lines of evidence saying that the strongest storms have already started to get stronger.
The Category 5 measurement comes from something called the Saffir-Simpson scale.
It was developed in the late 1970s by Saffir and Simpson. In around 2010, it was changed by National Hurricane Center to just be a scale of wind speeds. Category 5 and really even Category 4 were considered to be pretty much absolute destruction. Officially Category 5 is 157 miles an hour and stronger.
The scale follows its own mathematical logic on how to measure a Category 1 storm versus a 2 or 3 or 4. When Wehner compared that algorithm to the measurements of recent hurricanes, he made a startling discovery.
We sort of looked at the way the scale expands, because the range of wind speeds for 3, 4, and 5 expands. And so we use that algorithm and say, okay, using that, we can say Category 6 would be 192 miles an hour or greater. And so then we looked at the observational records in the satellite era, so that starts in 1980. First of all, we found that there were more Category 5 storms in the second half of the record than in the first half of the record. So that's sort of suggesting that there's a shift in the stronger speeds. But then when we put this Category 6 thing on, we found that there were 5 storms that reached these wind speeds.
192 or higher.
And all 5 of those were in the last decade. The first one was Typhoon Haiyan.
This is what the inside of a super typhoon looks like. 250-kilometer-an-hour plus winds slamming into a city. A white haze of screaming noise, smashing windows, tearing metal, water and flying debris.
That was a deadly storm that killed thousands of people in the Philippines.
This is probably one of the top 12, so the top dozen of all storms ever seen on this planet.
Impacted millions, it caused billions of dollars in damages. It's a major, major disaster for the Philippines. It also included Hurricane Patricia.
Hurricane Patricia, which exploded overnight from a tropical storm into a Category 5 hurricane in the eastern Pacific.
This is the strongest hurricane ever recorded in the Western Hemisphere. Its winds right now far more powerful than Katrina and Sandy.
That was the strongest storm ever recorded, with peak wind speeds of 213 miles an hour. So way above our threshold. And I like to say that's faster than a racing car. It's almost almost hard to fathom. But so the first line of evidence was this observational thing that, there seems to be a change in the most strong storms that recently has occurred. But, I'm a pretty conservative scientist when it comes down to it, and we really needed more. Then we went to climate models and we calculated it again and showed that in simulations with climate change compared to simulations where we don't have climate change, and we could show that it's the presence of the increased carbon dioxide that's causing this trend in the potential for Category 6. So that was our second line of evidence. And then our third line of evidence goes back to these models I was telling you about, these high-resolution models. I picked the three best. There's about a half a dozen or 10 of these models out there. And we looked at how many Category 6 storms it made under simulations of today or a pre-industrial world as well. And basically, it didn't make any in the pre-industrial simulations. Some of the models made a few now, and they all made a lot in the mid-century and end-of-century warming scenarios, which we're currently at 1.3 degrees above the pre-industrial levels. We looked at 2, 3, and 3.5 degrees warmer than pre-industrial. And by the time you get to 3.5 degrees, if these models were correct, there would be a Category 6 storm somewhere on the planet every year on average.
Well, you've talked a few times here about climate change and the science of all of this, and so I want to dig into this a little bit. Give me a basic understanding, as you were starting to a moment ago, of how do hurricanes start, and why is a warming climate making it even richer for hurricanes to get more frequent and stronger?
So you have to have everything lined up in a row for a hurricane to start. You have to have a lot of energy that usually comes from the warm surface waters of the ocean. You also have to have a fair amount of humidity in the atmosphere, so the air has to be moist. Then you also have to have low wind shear. Now, wind shear is the difference between the background winds at the surface versus at a high altitude. If that difference is too high, then the storm tends to tilt and doesn't really form very well. And so if the wind shear is low, the humidity is high, and the temperatures are high, you have the potential for a storm. You have to have one more thing, and that is some kind of disturbance has to come through to start it spinning. So how does climate change fit into this? Well, climate change is pretty simple. We don't really expect the wind shear to change too much with climate change, but the ocean temperatures and the atmospheric humidity do. That energy from the high temperatures is the fuel for these kinds of storms. And climate change, of course, is making things warmer, and so it kind of makes sense that the strongest storms are getting stronger.
While Wehner is advocating that we consider the documentation of these Category 6 storms to be a clarion call about climate change, actually changing the Saffir-Simpson scale isn't really the point.
The media and people, the single number of the category, the Saffir-Simpson category, wind category, is convenient, but it's not the best way of communicating impending danger from a storm.
Whether we add a Category 6 distinction or not, at the end of the day, the destruction from these storms comes from more than just wind speed, something even harder to calculate.
The problem with the Saffir-Simpson scale is it is only about the wind. And it turns out that most of the damage in hurricanes in the U.S. and elsewhere is not from wind, but from water. This hurricane that was last year, I guess, Hurricane Ian, is a good example. Hurricane Ian had two kinds of flooding, saltwater flooding and freshwater flooding. The saltwater flooding was what happened at Fort Myers. They had a 15-foot storm surge. So the winds pushed the ocean to be 15 feet higher, but also very large damages come from inland freshwater flooding from the rainfall. And what's happened in the last decade or so is the National Hurricane Center has put out a number of other products, maps, for instance, particularly, as well as verbal warnings that are far more useful for people to determine what danger they might be in if they're in the path of a storm. They've actually used the phrase more than once, certain death. You can't get any stronger in your warning than that. I mean, if you stay here, you're going to die, is what that means. And so, category number has nothing to do with that. And so I urge people to not fixate on the Saffir-Simpson number, but rather refer to these products at National Hurricane Center, which, the Weather Service puts out, the local TV usually puts out, but they have their own website, which is pretty easy to navigate. Because sometimes, a Category 5 storm isn't as damaging as a Category 3, and so, people need to recognize that, that the number, boiling this down to a single number is a little too oversimplifying. So we're fine with not adding Jim Costin, my co-author, and I are fine with not adding the Category 6 to the official scale. But we do think that it's worth talking about so that people understand that the risk of major hurricanes, whether it be Category 3, 4, 5, or 6, is increasing because of climate change.
Calculating the increased risk of a storm due to climate change is one thing. But what about calculating the increased destruction when it's over? That's after the break. Want a front seat to see the future of social impact? Tune in on May 21st for the finals of the John Edwardson Class of 72 Social New Venture Challenge. UChicago social entrepreneurs will compete for more than $150,000 in startup funds. The Edwardson SNVC, run by Chicago Booth Rustandy Center and UChicago's Polsky Center, is the social impact track of UChicago's nationally ranked New Venture Challenge, and has launched more than 200 mission-driven ventures that collectively raised $165 million. Don't miss the finals. Register now at bit.ly/SNVC2024. Have you ever wondered what goes on inside a black hole? Or why time only moves in one direction? Or what is really so weird about quantum mechanics? Well, you should listen to Why This Universe. On this podcast, you'll hear about the strangest and most interesting ideas in physics, broken down by physicists Dan Hooper and Shalma Wegsman. If you want to learn about our universe, from the quantum to the cosmic, you won't want to miss Why This Universe, part of the University of Chicago Podcast Network. Wehner doesn't just use these powerful computer models to predict the risks of storms. He is also a pioneer of a completely new form of storm research.
So I'm calling it end-to-end attribution. Some people call it impact attribution as well.
End-to-end attribution refers to calculating exactly how much more destructive a particular storm was due to climate change. In other words, if companies and governments hadn't polluted X amount, Y number of lives could have been saved, or a Z amount of property wouldn't have been destroyed. And while they aren't perfect yet, it's easy to see how these sorts of calculations could be politically and legally revelatory. His latest work on this revolved around Hurricane Harvey.
Hurricane Harvey was a large storm that stalled over the greater Houston area.
This is a hurricane with a 1-2 punch. The first is the traditional punch that a hurricane delivers, which is storm surge and high winds. But after that, we're talking about days and days and days of rain, because this hurricane will be stuck in place.
This is astounding. Some places got 5 feet of rain.
My goodness.
My goodness, yeah, exactly.
Greater Houston remains paralyzed, a region of 6.8 million people sheltering in place as the flooding disaster unfolds.
What we did is called an attribution study, and there was a degree of warming in the Gulf of Mexico. And remember, the warm water is what fuels tropical storms and hurricanes. That caused a 19% increase in the rainfall. And that caused a 14% increase in the flooded area over the greater Houston region. And that caused a 32% increase in the number of flooded homes. Now, the cost of Hurricane Harvey is estimated by NOAA to be $155 billion. And so if we make a crude assumption that all these homes were equally valued, which I think is not too far off, averaging over everything, we could say that 1/3 of that $155 billion, or about $50 billion, is the cost of climate change in Hurricane Harvey.
Additional cost on it.
Right. It costs $50 billion more because of climate change. We also applied, this is with Kevin Smiley at Louisiana State University, we also applied this to census data, and we found that the low-income Hispanic population was disproportionately affected. About a third of Harris County is low-income Hispanic, but about half of the flooded homes were low-income Hispanic, and so we're calling that an environmental injustice. About 5.5 million people were flooded in that event, and about 500,000 were flooded because of climate change. And we have tried to quantify this environmental injustice. And we find that there's a sort of an existing environmental injustice without climate change, and that is exacerbated because of climate change, particularly as the floods get deeper. And that actually was in a series of 3 different papers. And actually, we're working on another one now, further analyzing the social aspects, the social science aspects of this. And so it's challenging because it's really cross-disciplinary. I like to maintain that the most interesting questions in science are not within the disciplines, but when disciplines, meet. Those are harder because of a lot of different reasons, not the least of which is the language of social scientists is different than the language of physical scientists.
As I was getting ready for our discussion, I was doing a little bit of research, and interestingly, even a story popped up on CNN today about a man who last year had paid for a small condo $1,000 in homeowners insurance. This year, it had gone up to $9,000, and he was having a hard time even getting it. And they were talking about the costs of the storms and why they're getting so much higher and almost making certain parts of the country, if not the world, uninsurable. Talk to me about that, if you would.
This is indeed happening right now. This is maybe one of the more direct or certainly more quantifiable impacts of climate change. So, along the hurricane-prone parts of the Gulf, it is very difficult to get insurance. If you can get it at all, it's expensive. But it's also true here in California. The insurance because of fire has become prohibitively expensive.
Right.
And it's quite clear that the wildfires have become more severe in the last 3 or 4 decades, and a large fraction of that increase in fire damage is due to climate change. I don't think this is nearly as well studied as the hurricanes. It's a somewhat more difficult problem, but it's quite clear to me that there's a cause and effect here. So throughout the Western United States, insurance rates are going up in the rural areas and where a lot of people want to live. Insurance rates are going up really strongly in some of the coastal areas, to the point where there are no insurance companies that are willing to insure it at all. And so what does that mean? Well, that actually has pretty profound social implications.
It absolutely does.
So if you can't get insurance, your house is destroyed. Okay, let's say it's destroyed, and you can't get insurance to insure a new property. You can't get a loan. If you can't get a loan, the only way you can build is if you've got the money, you got the cash, which means that only rich people who can self-insure would be able to rebuild in these areas. And so that's going to change the character of these neighborhoods from whatever that is, in terms of the mix of incomes to just the uber rich. Because, how many people can afford to build a house and be able to afford to take a total loss next time a hurricane comes through? I mean, that's nobody I know.
That's a very small number. Yes.
It's a pretty small number. So that has pretty profound implications. And then there are other implications too, like, when infrastructure is wiped out because of, bridges or roads or what have you, because of a storm, does it make sense for the state or the federal government to rebuild these things, given that the vulnerability of this infrastructure has been increased because of climate change? And so
absolutely,
that leads to a concept people often refer to as managed retreat, where you make some high-level decision that you're not going to rebuild these things, or you're going to relocate a town.
Right.
And of course, this is a very traumatic event.
You were talking in the beginning of our conversation, Michael, about the abilities to get greater predictability from as the climate models advance. And I'm wondering, as you look forward, and now we're getting supercomputers that maybe within 10 years will be online, or rather quantum computers could be online, and the predictability of some of these models goes up. What is the advantages of getting greater predictability, and where do you see that taking us?
I've long argued we actually know more than enough now in action about climate change.
I would think so too.
We're not. I mean, there's a lot in the pipeline that's just going to happen no matter what we do. We don't seem to be, the actions that need to be taken to really stabilize the climate are expensive, not particularly politically popular, and simply aren't happening. Then, so instead of mitigating this risk, we need to adapt to it.
What does adapt mean as you talk like that? What does that mean?
Like what we just said, I mean, recognizing what parts of our society and what segments of our society are most at risk and taking actions to lower that risk. And so for hurricanes, it may be changes in building codes or changes in, where people can actually live. The same with fires. I mean, reducing fire risk or reducing heat wave risk. I mean, there's a lot that can be done for reducing heat wave mortality simply by educating the public about the dangers of high temperatures. I mean, what I have to say is very depressing. It's not, particularly happy message, but I do like to remind us that, humans are adaptable. We've adapted to many things over the course of our existence, and we can adapt to this. The sooner we start changing our behavior of how we get our energy and changing our behavior of how we respond to extreme weather, the better off we are.
Big Brains is a production of the University of Chicago Podcast Network. We're sponsored by the Graham School. Are you a lifelong learner with an insatiable curiosity? Access more than 50 open enrollment courses every quarter. Learn more at graham.uchicago.edu/bigbrains. If you like what you heard on our podcast, please leave us a rating and review.